the jump statements as the target address where we have to jump to. That instruction address has not been generated yet. So how do we fill that? The solution is that we will leave the go-to's target address as blank and we will fill it when we get to know the target address later on. Okay? So we will make a list of or next list that will hold the address of the instructions where a blank go-to statement is there, and whenever we know that target addresses instruction is generated, we will come back in this next list and fill those blank instruction numbers with that address. That is the method. Okay. So let us first write the grammar rule. Okay. S derives if when condition B M S1 or if B M1 S1 N else. Why is this N is there? We will see this N is used to generate a go-to statement. Yeah, because after executing inside, when the B's condition is true and we go inside the if control block, after executing the inside of the if control block, we have to jump out of the if statement. Otherwise, else will also be executed. We don't want that. That's why N is there. Okay. M2, S2, or now a while statement, while M1, B, M2, S1, or, so if is there, if else, while, and then inside curly bracket, the body, L, assignment statement. I think they have written as 1, 2, 3. Yes, they have written. Then L, there can be multiple statements, L1, M, S1. Yes. N derives epsilon, M derives epsilon. Okay. Now we will one by one for each of the rules we will write the semantic rules. Okay. S derives. Okay, let us change the color. That will be better. Let us use red color. So first rule. S derives if B M S1. What would be the semantic actions over here? We have to generate the 3 address code. Okay. I know that if B condition is true, the jump statement's target address will be M, right? So we will backpatch as we know the target address over here. So we will backpatch B's true list. B dot true list with M dot instruction. Okay. And I know that inside the body of the if statement, if there is a jump statement, then it will come out of this entire if block. That means S dot next list. Okay. What would be S dot next list? S means this entire if statement. We have to jump from this entire if statement. X dot next list, but we don't know the target address yet. So we will just maintain a list of these missing, empty, right, blank go-to instructions. That would be, we have to merge, right, B's false list and S1's next list. Merge. B dot false list and S1 dot next list. Then second is S derives this first. Backpatch b dot true list with b's true list with m1 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 dot next instruction. Backpatch b dot false list with m2 m2 next instruction. Okay, then what next? Okay, true and false we have done. Now we have S1. Okay, whenever, how we will come out of this if else block? If there is a jump instruction in this S1, okay, if there is a jump instruction in this S1, then we will come out of this entire if else block, right? So S's next list will be S1's next list, and we know if we finish executing inside this if statement, we have to come out this entire if else block. So S1 next list, N next list, and S2 next list, all these are blank go to instructions that will come out of this entire if else block. So what we will do is, we don't have space over here. So I'll just continue on the next page. Okay, we have where variable, as this merge function, it takes only two arguments at a time. So we will create a temporary variable temp, and we will merge S1 dot next list, yeah, and N dot next list. Okay, and then in S dot next list, we will simply merge this temp with S2 dot next list. Okay, this is 2. So here our, yes, we have completed the semantic actions. Now we will go for the next rule, that is while, right? Now this while, S derives while M1 condition M2, yeah, S1. Okay, now we will write the semantic actions. Okay. Note, okay, now let us note that whenever our B condition is true, we will jump to M2. So we will backpatch over here because I know the target of the goal. Then whenever there is a jump statement inside the body of the while loop, right, where is a jump instruction like break, we will just go back to the next iteration of the loop, that is we will come to M1, right? S1 next list will be M1, right? And I have to generate a go-to statement after this. Suppose inside the body of the while loop there is no go-to or break or continue. Then in that case, I have to generate. It's only assignment. Then I have to generate a go-to, uh, right? And there has to be another go-to after S1 as well. Because if there is only assignment in S1, right? So what we are going to do for, we will first backpatch b dot true list with m2 dot instruction. Okay, then if, yes, yes, then x1 whatever instructions are there in next list, we will backpatch it with m1 dot instruction. Okay, okay, okay. Now, what outside this while loop, what will be there outside this while loop? Whenever B's condition is false, we will come out of the while loop. So S dot next list means entirely outside this while loop will be B dot false list, correct? And only one way to exit when B's condition is false, right? And then we will generate an explicit go to, and then I know the address, right, where we have to go to m1 dot uh, next instruction, right? m1 m1 dot instruction, right? m1 dot instruction. An explicit after this s1, a go to will be generated to m1 dot instruction. Then next what we have to next is the body L, right? Okay. Number would be 4. S derives the body L. So whatever go-to statements will be there, they will come out of this entire block, right? So and we don't know the target address. Yes, so simply we will do s dot next list will be equal to L dot next list. Fifth, S derives the assignments. Now in assignments there are no jump statements, so S dot next list will be equal to null. No jump statements at all, empty jump statements at all. Then we have L, the body, right? The body can have multiple statements, so L1 M S S1. No, we can keep only S. Now if there are go to statements in this L1, we have to jump to the next instruction. That is, we have to backpatch. Backpatch L1 dot next list to M dot instruction. Okay, right? And what is after this entire block? S, right? L dot next list is equal to S dot. And if there is only a single statement in the body, then in that case, L dot next list is equals to S dot next list. Okay. We will see any rules left. Yes, N M M, right? N M M. N derives epsilon. Now, this N was generating a go-to in the inside of the if block, right? So we have to generate a go-to statement, blank go-to statement over here. N dot next list will be equal to, we will make a new list. Make list and put the instruction number of the next instruction. Next instruction. Okay. And then we will generate a blank go-to. Okay. And N dot instruction 9. M derives epsilon. It will just pass on M dot instruction would be equal to the next instruction. Okay. So this is it. This is a little bit confusing, so what I recommend is you write the rules on your own and generate the code, three address code for an example of the control flow of control statements, then it will be crystal clear. So hope you like this video. Please like, share and subscribe to my channel for more videos, and stay tuned. Happy learning.